guys, welcome back to my YouTube channel. So our topic for today is hypothesis testing with unknown variance. Okay, so a pediatrician has claimed that the average weight of 12-year-old children is 104 pounds. However, there is a report that the average weight of 25 children is 114 pounds. With a sample standard deviation of 20 pounds, is there evidence that the average weight of 12-year-old children that is greater than 104 pounds at a significant level of 0.01. So this t distribution or the t value, this applies to the samples which is less than 30 with an associated standard deviation as long as the variance of the population is unknown. Okay, so we're going to discuss here. So we're going to state the given. So our step one here is, okay, so we're going to identify the population mean. This is the null hypothesis first, then this is the alternative. Okay, so we're going to apply the same steps of hypothesis testing. So our population mean here is 104 pounds. Okay, so based on the claim of this problem, okay, since we are going to test if there's evidence that the average weight of 12-year-old children is greater than 104 pounds at a significance level of 0.01. So what are we going to do is we're going to indicate the greater than sign, so which is the alternative hypothesis. Or we can state that mu is less than or equal to 104. So that is the null hypothesis, while the alternative hypothesis states that the population mean is greater than 104. Okay, so we're going to identify what is given. So our significant level is 0.01. Okay, then we're going to state the population mean. Then we're going to state the sample mean. So our sample mean is 114. Then our sample size is 25. Then our standard deviation, which is small s, which is 20 pounds. Okay, so now we have stated all the given. So now we're going to move to step 3. Okay, so before using this t distribution, we need to identify which tail of test are we going to use. So since there is a certain inequality which is greater than, then we can tell that this is a one-tail test. Okay, so since this is a one-tail test, okay, so now we're going to use this table, but before that, we're going to identify the degrees of freedom. So if n is equal to 25, then our degrees of freedom is 24 because 25 minus 1 is 24. So that's how we find the degrees of freedom. So in order to find the degrees of freedom, we're going to subtract the sample size with 1. Okay, so here we're going to locate the degrees of freedom. So we're here in the one-tailed. Okay, so we're here in this one-tail. The significance level is 0.01. Then the degrees of freedom is 24. So we're going to highlight. Okay, so we're going to draw a line that corresponds. So here, so our t-value is 2.492. Okay, so drawing this normal curve, okay, so this is one-tailed. So we can write it here, 2.492, then we're going to shade it to the right. Okay, so this is the visual representation in terms of the regions of the normal curve. Okay, so what are we going to do next is we're going to solve for the t-test statistic. Okay, so let me recall the formula. So sample mean minus the population mean, then divided by the sample standard deviation, then multiply by the square root of n. Okay, so now we're going to state what is given. So when we say the sample mean, this is 114 minus 104, which is a population mean, then the S is 20. Okay, so what are we going to do is we're going to find the square root of the sample size. While finding the square root of the sample size, we're going to simplify for the numerator. So 114 minus 104 is 10, then over 20, then the square root of 25 is 5. So therefore, 10 times 5 is 50 over 20. So 50 divided by 20, which is 2.5. Okay. So this is our T statistic, the test statistic. Okay. So now we're going to proceed to the fifth step. So we're going to compare this T, the critical value. So this is the critical value. Okay. Then now this is the test statistic. Okay, so what are we going to do is we're going to compare. So since 2.5 is greater than 2.492, okay, so we can say that we're going to reject the null hypothesis. Why are we going to reject the null hypothesis? Because this satisfies the alternative hypothesis. And in addendum, okay, so in addition, okay, so this is the normal curve. Okay, so since 2.5 is here in this region, so we can tell that we're in the rejection region. So in step 6, okay, so we can interpret that there is evidence that the mean weight of 12-year-old children is greater than 104. So it means to say that the claim is correct. Okay, so it means to say that there is significant difference between the means. Okay, so next problem. A researcher has reported that the average grades of grade 11 students in mathematics is 83. However, there is a report that the average grades of 60 students is 78. With a sample standard deviation of 25, is there evidence that the students have received an average that is lower than 83 at a significant level of 0.05? So we're going to repeat the same step, okay? So our first step is to state both of the hypotheses, which are null and alternative. So for the null alternative hypothesis, we can tell that the mu is equal to 83. Then, based on the last statement or the question, okay, so we're claiming that the students have received an average that is lower than 83. So what are we going to do is we're going to state that this is less than 83. Okay, so in opposite, mu is greater than or equal to 83. So this is the step 1. While the step 2 is we're going to state the given. So our alternative or oops, so our significance level is 0.05. Then our population mean is 83. Then our sample mean is 78. Our sample size is 16. Then our standard deviation is 25. Okay, so now we have stated all the given. So what are we going to do is We're now in the third step, so we're going to identify the critical value. So then again, we're going to identify if it's one-tailed or two-tailed. Why do we need to do this? Because this will help us to find the critical value that corresponds to the concerned degrees of freedom. So, okay, so since there's a certain inequality indicating that this is less than, we can tell that the tail is a one-tail test. Okay, so let me write this to go on detail. Okay, so since this is one-tailed, okay, so we can go to this significance level, which is 0.05. Okay, so now our degrees of our sample size is 16, then our degrees of freedom is 15 because 16 minus 1. Okay, so what are we going to do is we're going to locate this corresponding t-table, the t-value. So our critical value is 1.753. So this is our critical value for this problem. However, since the null alternative, the alternative hypothesis has indicated that this is less than, so we can tell that it must be negative. Okay, so using the normal curve, so here this represents. So the critical value must be negative kasi less than siya. Okay, so now we're going to shade this. Okay, so what are we going to do is we're now going to the step 4. Okay, so what are we going to do is to solve for the test statistic. Okay, so our sample mean is 78 minus 83. Then our sample standard deviation is 25 times 10 square root of 16. So what are we going to do is we're going to subtract, which is negative 5 over 25 times square root of 16. So what are we going to do here is we're going to find the square root of 16, which is 4. You're right. So, but to make things clear, okay, so we're going to copy negative 5. Okay, so to produce a step-by-step method or a procedure. Okay, so negative 5 times 4 is negative 20 over 25. So dividing, so it will become negative 0.8. Okay, so now what are we going to do is we're going to recall the rejection region. So this is negative 1.753. So this is the rejection region. So since negative 0.8 is greater than negative 1.753, okay, so since this must be less than based on the alternative hypothesis and based on the normal curve, we can tell that we have to accept the null hypothesis. Okay, so this unshaded area represents the acceptance and the shaded region represents the rejection region. Okay, so regarding the step 6, okay, so now we are going to make an interpretation. So it means to say that there is no evidence. So it means to say that there is no significant difference that the students have received an average lower than 83. So meaning to say that we accept the null hypothesis, leading us to conclude that there is no significant difference nor evidence. So we cannot claim that the students have received an average lower than 83. So it means to say that there is no evidence at all. Okay? So that's how we interpret based on our decision on the hypothesis and the test statistic. Okay, so here, so this might be challenging because there's no given mean and standard deviation. Okay, so now what are we going to do here is to find the sample mean. What are we going to do is 16 plus 18 plus 19 plus 16 plus 17 plus 15 plus 19 plus 20 plus 17 plus 18 over 10. Okay, so adding them all, so it will be 175 divided by 10, so it will become 17.5. So this is our sample mean. So here we are going to state the given. So this is easy for us to state the given because we're now computing for the sample mean. Okay, so the population mean is 17. Okay, to get the sample standard deviation, okay, so what are we going to do is, this is very long. Okay, so please be patient. Okay, so what are we going to do here is, so this is, okay, we're going to form a table. Okay, so this will be 7, 16 minus 17.5. It will be negative 1.5, then square, it will become 2.25. Then 18 minus 17.5, it will become 0.5 squared, it will become 0.25. Then 19 minus 17.5, it will become 1.5 squared, it will become 2.25. Then this will become 16 minus 17.5, it will become negative 1.5 squared, then so on, then so forth. Okay, so 17 minus 17.5, it will become 0.5. So negative 0.5 squared, it will become 0.25. Then 15 minus 17.5, it will become negative 2.5 squared. It will become 6.25. Okay, so 19 minus 17.5, it will become 1.5 squared. It will become 2.25. Then 20 minus 17.5, it will become 2.5 squared. It will become 6.25. Then 17 minus 17.5, it will become 0 squared. It will become 0.25. So this process might be painful, but it will surely make you practice on how to find the standard deviation. Then 18 minus 17.5, it will become zero point 0.5, then squared, it will become 0.25. So now we're going to add everything. Okay, so adding everything. So, okay, so what are we going to do here is we're going to perform some addition. So you can use your calculator. So you will not get much confused since very mahaba ito and very matrabaho ito. But I am sure that once you understand this, this will be worth. So in understanding statistics, it requires a lot of patience and determination. Okay, so this is 2.25. So adding all of them, this will become 2.25, 22.5. However, this is the sum. We're looking for the sample standard deviation. Okay, so 10 minus 1. So what are we looking for is the sample variance first. Okay, so 22.5 divided by 9, which is 2.5. Okay, so looking for the sample standard deviation, we're now going to square root the 2.5. Okay, so the answer is 1.58. So I have decided to round it up to two decimal places, so it will be simpler to compute. Okay, so going back to the hypothesis testing step, so our step one will be H sub 0, then H sub A. So to identify each of them, we're going to read the problem. A guidance counselor has claimed that the mean age at which students graduate their high school studies is 17 years old. The following data give the age at which 10 randomly selected students graduated from high school. So here are the following ages. Is there evidence that the students have received an average that is lower than 83 at a significance level of 0.05? Okay, so what are we going to do here is to state the null hypothesis. Okay, so our mu is equal to 17. However, regarding the alternative hypothesis, okay, so, oops. So I forgot to make a correction here. So here's my mistake. So let me correct my mistake here. So here, so is there evidence that students have graduated at an average age that is not 17? Okay, so forgive me for my typographical error. So here is the correct problem. So is there evidence that students have graduated at an average age that is not 17? So the claim is the average age of graduating high school is not 17. Okay, so our alternative hypothesis is not 17. So in step 2, we can tell that the significant level is 0.05, then our mu is 17, then our sample mean is 17.5, then our S is 1.58, then our N is equal to 10. Okay, so can I just fix my handwriting? Kasi my handwriting is so poor. Okay, so let me fix my handwriting so everyone can understand how I write. Okay, so here. This eraser is kaloka. Have graduated at a mean age that is not 17. So it means to say that we're trying to claim that the students have graduated high school at an age which is not 17. So bale hindi 17 ang age ang kiniklaim natin. Okay, so since there's no specific inequality or comparison, so we can tell that this is two-tailed. This is two-tailed. Okay, so looking for the critical value, according to how many tails, let me find the degrees of freedom. So 10 minus 1, which is 9. Okay, so we're going to correspond here. So this is two-tailed, which is 0.05. Okay, so now we're going to look for this. Okay, so this is 2.262. Okay, so our critical value is 2.262. So here is our curve. Okay, so forgive me for my drawing since my drawing is not that good here in this computer. Okay, so here, so we have two rejection regions since this is detailed. Okay, so now we're going to compute for the t statistic. Okay, so we're going to mention the formula so we can be able to practice again and again and again and again. Okay, so our sample mean is 17.5 minus 17, the population mean, then 1.58 is the sample standard deviation, then our sample size is 10. Okay, so now we're going to compute. Okay, so this will be 0.5 over 1.58 times square root of 10. Okay, so now we're going to compute. Okay, so diretso na tayo sa pagko-compute para hindi na tayo masyado malito pagdating sa rounding off. So this will be 1. So this is our t-value. Okay, so constructing this normal curve, negative 2.262. Oopsies, this is two-tailed, so plus minus. In here, this is 2.262. Okay, so here lies 1.0 here. So we can tell that we accept null hypothesis. Okay, so in step 6, there is no evidence that the students have graduated high school at an age, an average age, which is not 17. Okay, so here is our claim. So since we accept the null hypothesis, it is claimed that there is no evidence that the students have graduated high school at an average age which is not 17. So it means to say that the students have graduated high school at an average age of 17. So we are in the null hypothesis. Okay, so we're going to have a warm up regarding the T and the Z. So the Z test is being used when the variance for the population is known or the sample size that is greater than 30, greater than or equal. However, we're going to use the t-test or the t distribution if our variance for the population is unknown and if the sample size is less than 30. However, in some of the problems wherein the sample size is less than 30, it can be used for the z-test as long as there is a population variance or the variance that is associated with the population. In these problems, okay, as we see that there is no variance that is associated with the population, but instead there is a variance or standard deviation that is associated with the sample. That's why we call sample standard deviation or sample variance. Okay, so do not forget to subscribe my YouTube channel and hit the notification bell. So thank you and God bless and have a great day. Stay safe. Happy learning.